Okay, see 495. Today I'm gonna just record for the next step. I assume that every team just completed your 3D model so that we are moving into the lateral system design. Just one thing I like to double check and let you know is just column design. I know we are currently using auto selection columns, right? So when you drew all the column, I assume you're using section frame and auto lateral column. When you open it, I think default, you see that oh, the lateral column. Wow. So typically we, for the column design, we normally use W14, not right. And since we are designing a huge tall building, I'll just stay with all W14. So this is almost the dimension between inner face of the flanges to flanges, they are mostly constant, so make it more easy the splice connection. All right, so I'm gonna just only keep this W14 sizes. I'm gonna save it, right? So this one should have only W14. So so you should actually use and size the W14 by W14 series for your column design. Obviously, the ETABS will choose the sections size based upon your design load, especially for gravity load. All right, so now we'll just you maybe can you redesign it if you can, but because I see some W4 8 by 21 and W10, I think it's a relatively small the sizes. We usually don't use this W8 or W10 for the high-rise building things. All right, now I'm gonna move to the lateral system. Since we don't have any architect here, but that doesn't mean we cannot design that core wall layout. Or what I try to point out is, because this building, right, and has to serve for all the tenants, that means we need to kind of provide some kind of corridor. So wall cannot be just a solid wall. Instead, this one we should actually provide the opening so that one side we may have elevator bank and stairs, so that we have to redraw the wall here, which we don't have any wall opening. So let's see what, at this point we have two choices. We can redraw the wall, especially this, the face. Maybe, you know what, I maybe have to, oh boy, okay, turn off. Oh, what's going on? The beam, I'm gonna turn up the beam wall opening beam. Okay, I'm gonna turn up the, where is opening? Okay, so there are many ways to adjust it or redraw it. Since what I'm gonna do is I'm gonna provide the opening here and here and here, so we can provide some corridor. Let's see. Obviously, especially this building, we are dropping the core. So okay. Okay, so what I'm gonna do first, I'm gonna just use this old stories. So I'm gonna just select all this wall, right? What I'm gonna do is I'm gonna mesh it in 1/3. Okay, so go to the edit and edit shell and divide the shell, basically 1/3. Let's say either this is 1/3 or 3/1. So yeah, seems like this one should be the other way around. So I'm gonna select again and make 3/1. So you see that those wall, big panel of wall will subdivided. Oh, okay, did I mesh this one too? Or it was like this? Okay. Okay, so anyway, so since I subdivided, so I can select in the middle the panel of the wall, select all, I delete all. So you see we basically, I'm gonna turn up this, and then I'm gonna turn up the node, so you could see this. The wall is most likely either I shape. Let's go all the way to top. You see that we have some opening here, and the lower, yeah, we make opening. So now, we already meshed it. This may be the much easiest way to do this. But now, since the wall is segmented and subdivided, we need to brace it. So basically, what that means is here we need to provide coupling beams. Since at this point we haven't set it up the wall sections, so now it's time to set up the wall sections with various thickness and concrete strengths. Let's see what we have. Okay, first of all, in default we have only 4,000 psi concrete, which we need to use high strength concrete, right? So I'm gonna copy from 4,000, right? So I'm gonna just, let's say 9,000 psi. I'm gonna just create the 9,000 psi concrete section properties. What only you need to change it here is Young modulus. So either you could calculate the Excel typical normal weight concrete F'(C) and Young modulus, right? 4,000 equal 57 times square root F'(C). So this is KSI of Young modulus. So here I'm gonna add (1,000) to, let's say we can use 9,000. Okay. So you could either calculate the Young modulus and type it, right? So Young modulus equal 57 times square root F'(C), right? So it's a proportional to the square root F'(C's) ratio, right? So either you could type it, this is KSI, or since the ETABS has a built-up calculator, I'm gonna use SQLC, but because this is based upon the 4,000, I'm gonna just put some ratio, right? Square root ratio of 9,000 versus 4,000. So I can calculate this. This is PSI. You can see this. So 9,000 is 5407.47, right? Roughly, yeah, those are same. So this is PSI, so 5404. Okay, so you can use a built-up section, built-up calculator. So I add 9,000, but I'm gonna create a few more. 8,000. Again, asterisk and 8 divided by 4. So this is a Young modulus for 8,000, right? And then I'm gonna create a few more. 7,000. Right? So make sure your unit is consistent and correct. So 6,000. And I'm gonna create another 5,000. 5 divided by 4. Okay, so this is Young modulus. I create more concrete strength material. So I'm gonna save it. Okay, I'm gonna save it. So now I'm gonna start create more wall section properties. Default, you see the 12 inches wall. So W12, I'm gonna use it, but I like to put the some name associated with concrete strength. You know what? I think I'm gonna use 5 as a minimum. So 5,000 concrete, right? I just try to use as kind of prefix, a short name as much as possible. Otherwise, I'm gonna get confused. So okay, so this is default. So I think I'm gonna create W24 and C9, right? C9 and 24, right? 24 inch thick and concrete strength C9. So I'm gonna create W20, 20, 20, maybe C8, right? And then I'm gonna create another one, W18, C7, C7. Okay, so I create a few more wall section properties with associated concrete strength. Also, we need some beams because this wall has to be tight so that they work like a sideways, not prohibited system, because the wall is also like a C and I shape, channel C shape and I shape. It need to be braced so that actually increase the much their lateral stiffness. So what we're gonna do for now, since the wall thickness is started 24, depths we maybe assume maybe 30 inches, but we need to coordinate with architect. Typically, our typical floor, right, is 15 feet, so we can make a much deeper the beam sections. But I'm gonna just choose here and create the section property. This time, link beam. Beam the width. Usually we match with wall thickness, so that easy to create the formwork. So 24 inch wide, right? And let's assume 30 inch wide, right? 30 inch depth. So the lowest one, I'm gonna use the same concrete strength. So width 24 and depth 30. And this one, same thing. I'm gonna put some concrete strength here. So this actually give me that 24 by 30 concrete strength C9, right? Okay, so I'm gonna create a few more and copy link beam 24 by 20. I create 20 inch wall, 30 C8, 20 inch by 30 and C8, right? Then I'm gonna create a few more, copy link beam 18 inch by 30 C7. So 18 by 30 C7. So I create section properties. So all right, so let's see. So now I will see either I can draw everywhere and delete it, or I maybe draw the one and copy. It's up to you. Maybe we can try draw the one beam here, which is beam is now concrete link beam LB, right, at the low floor, 24-inch wide. So I'm gonna draw, make sure this concrete is continuous, it's not like a steel, right? So I'm gonna draw what's going on. Okay, gonna zoom in. Yes. Gonna zoom in. Click. So, oh, I need to turn on the beam. So I draw the link beam here, link beam there. Okay, so this is the link beam is really working very hard, so I'll just explain later, but we need to set it up this. For kind of easy operation, maybe we can kind of set another draw elevation reference plane. Okay, let me see. Where is it? I'll draw the grid, draw dimension, or maybe you can draw the grid. Okay, so you know, Control D, you could show all the grid. Oh, we already have grid C. Okay, and 4. Okay, good. C and 4, we already have the grid. Grid C, no, 4 and 6, right? So 4, 6. See that I drew the link beam. If you wanna click, oh boy. If you wanna just extrude, yeah, you could see the beams here, 30-inch wide, 30-inch, 24 by 30, right? All right, so you know what? I'm gonna select this, and I'm gonna copy up to 25. So go to Edit, Replicate, Story, up to 25 to Story 2. So I copy this link beam, right? And I'm gonna also select this beam and copy 41 to 26. So replicate story 41 to 25. No, 26. Right? So this is link beam. I just copy and actually draw for one time and copy. If you, okay, you could do that same way at the another locations, right here, or you could copy it over to Y direction, but I'm gonna just draw again up to 25. Okay, and then I'm gonna select this and copy 41 to 26. But obviously this link beam, oh, wait a minute. Yeah, actually, yeah, it's okay. This is still, but obviously the 24 by 30 is something that a good marriage with the wall thickness 24. So we need to also assign the link beam, right? To match the wall thickness. So go to 24. What you could see, maybe you could use section properties. So this is visually is using color code. So what is this? Oh, wait a minute. Oh, the wall thick. We haven't also assigned the wall. Okay, we didn't assign the wall. Okay, so what we're gonna do first, we're gonna assign the wall sections. So what I'm gonna do, I'm gonna put it in 3D and select all the wall for now. Assign the wall section up to here. You know what? Let's see, maybe up to here. 24, right? And select up to here. I'm gonna assign 20, right? This is also 18. So I just assigned the wall section properties along this height. Oh, I think the color 24 is red. Color 20. Oh yeah, I have to change the color for wall section 20. Okay, so you see that the wall section property 24, 20, 18, right? Now, similar to the link beam, but since everything is turned on, what we're gonna do, go to view and XY plane. I'm gonna select all up to here. Go to right click and show selected object member. I'm gonna only bring Control D, turn up. Oh, okay, this is link beam, right? I think I missed the wall. I missed the wall. Okay, I'm gonna go redo it. So show all. Okay, here. Right click. So let's see. Okay, because of this. All right. So what I'm gonna do, maybe I can select by properties as well. So select wall, right? Okay, select wall, and I'm gonna select property link. Here this time is a link beam, 3 link beam, and then right click and show select the only member. All right, so this is only all the concrete element, right? I select assign, maybe assign the group. So this is core. I'll name it core. Add the group. They changed the O. Okay. Group. Assign object to a group. Okay. So this I assign, those are all elements. This is now I assign as to group core. So next time I can select by group here, right? So okay, so now it's much now ready to assign the section properties. So I'm gonna go back to the section 4. What is those are all 24 by 30, right? So what I'm gonna do, this one, select all the beam, assign section property, and I'm gonna use link beam 20 by 30 because the wall thickness is 20. So I assign it, and also I select this beam and assign to link beam 18 by 30. So when if I turn on the wall thickness, wall section properties, right? This wall is 18-inch wall, right? And link beam is 18-inch wide, right? Same thing. Wall is 20-inch thick, link beam is 20-inch wide, right? Same thing. Okay, so we need to do that on the section, other section. Here I'm gonna select, assign, and to link beam 20 by 30, and select here, assign to link beam 18 by 30. All right, so okay, so first of all, I just somehow randomly assign the wall, define the wall section properties and link beam properties, but at least what I did is matching the link beam width to wall thickness. So just this is the one first random, the core wall profile I'm gonna use for first analysis. Okay, so let's see what I'm gonna get, especially for lateral deflection under the wind load and X and Y. Okay, and then its default is showing the dead load displacements. Okay, so I'm gonna just double check whether we have a wind load or not. We have a wind load. Okay, S is 716. Okay, basic wind speed is 115. Just remember that this is ultimate wind load, so that we need to scale down to make the service wind load. Since this is a wind load calculations, what I'm gonna do, I'm gonna create just one. So this is service wind, right? Which is 0.6 times whatever just wind ultimate. So whatever wind calculation, wind loads based upon 115 miles per hour, the load factor 0.6, which is typically similar to 1 divided by 1.6, right? But code just rounds down, so they're using 1.6 to scale down to service wind. So this is the service wind we're using for deflection check. Okay, so now I'm gonna show all. Right, I'm gonna turn on column, everything. Okay, and I'm gonna check, put it back to object member. Okay, so now going back to display and response spectrum plot, what I'm gonna try to see if the first of all story shear due to the wind. So I choose the wind load and story shear. So this is the shear force diagram, right? Cumulative shear force diagram. Since we have a wind pressure that's pushing the wall at each along the floor, basically when you sum them up, this is, you're gonna see the cumulative shear. Basically we are looking at the hallmark 1, right? Shear force diagram. But hallmark 1, we had only one kind of point load at the top, but in real building we should have all the wind pressure along the height floor. So this is something you could see that So this is when you the wind step number 1 means the wind is blowing in X direction. So story shear should be, or cumulative shear or base shear should is shown in blue color. You see that 3400, 3416.9 kips is a total base shear due to the wind. But this is ultimate wind load, right? So when you turn to 2, you see that wind is blowing Y direction. You see the red color. So wind is blowing Y direction, has a 30, 20. So kips, basically shear forces. You could just change to this overturning moment, right? Since wind is blowing 2, right? But it's showing the moment overturning moment is shown on the blue, means the wind is blowing in Y direction. So overturning, when we use it, we're using about. So this is moment about axis, right? Overturning moments about global axis is really induced by the wind is blowing in Y direction. So you see that moment diagram, overturning moment diagram. I'm going to show one again so you see the moment diagram, right? So now let's take a look at the deflection. So first, maybe we may have a few reference points, but center of diaphragm displacement, I'm gonna take a look at it, but now I'm gonna use service wind load. What do I see it? Why is show many what? Diaphragm center of displacement. Diaphragm B1. Whole story. User defined. What is diaphragms? Okay. Diaphragm center. Okay, something going on. Maximum story displacement. Why is show all? Oh, this is 24 case. Oh, this is something 24 cases. 12 cases. That's why it show all. Maybe I have to do the other way around. Okay. X direction, Y direction, maximum story displacement. No, this is not right. So let's see. Where next? Oh. Okay. I have to use the step 1. Okay. Sorry. All right. So I'm gonna just use story service wind load. Things I'm not okay. I cannot show something. Okay, so this wind load is ultimate wind load. We cannot use this way because somehow it show all this way. Okay, so what I'm gonna do, maybe create service wind load here instead of using load factor, and so this I'm gonna use this 98 service wind load. This cases here we have a total of 12 cases, but I'm gonna just separate it. So this is wind X service wind X, and then I'm gonna also create service wind Y. So this is service wind X. So 0 degrees, wind is blowing in X direction. The case 1, we have a total of 12 cases, but we're gonna use it just pure wind blowing in X direction. And this one, I'm gonna use a 1Y, but I need to change here 90 degrees so that wind is blowing in y direction. So I just create the wind load cases for wind x and wind y. So in order to can check the wind deflection based upon pure wind x direction and also wind y direction. But basically I'm trying to use the service wind load. Okay, so go to display and story plot. So I'm gonna choose service wind x, right? So you see that wind is pushing the building in y direction, x direction, which we have 10 inches at the deflection at the top 41st floor. And how about the wind y? Wind is blowing y, then we have a deflection of 9.8 right there. Now let me double check what is our floor to floor height. Okay, 15. Okay. Okay, let me see overall. Okay. So what is this width here to here? Oh, okay, 30 feet. Okay. So when you look at this building, I think you're more at the base is more square. So total wind blowing in x direction, y direction, they are very close enough, right? Close. But when you look at this, the core wall layout, obviously core wall is longer, rectangular shape. So stiffness wise, I think in x direction is steeper than y, right? But when we goes up, I think the wall actually drop. So the core wall is basically 30 by 24. Okay, it's not that much big difference, but somehow you will see that now the wind is blowing in x direction, has a more tributary width as much as this, right? 1, 2, 3, 4, 5, 6, 7, 8, 8 times 15 versus wind blowing in y, you have a tributary width is that's 72. So you could see there's something, the wind pressure demand and your stiffness of the concrete core wall slightly change along the height. So first things, so what we did, just we set it up, we check the deflection here. We want to make sure this wind deflection is less than our design criteria. So that is something that we're gonna just talk about tomorrow. But I'm gonna stop here. So I want you guys also set it up your all the lateral model, right? Just starting split the your core wall if you draw the solid wall, because in real building you need to give some space. This is like a corridor, so people actually come out and go enter their office space. So obviously this is some core accommodate the elevators, bank, and stairs, and some restroom. So you need to just divide the wall, and then define the material properties and section properties for wall and link beam, and you need to draw and assign all section properties so that you should be able to first complete the defining the lateral system. Okay, I think I'm gonna stop here, and then we're gonna maybe talk about again tomorrow.